The only steps I made, steps too high. I'm just a man. If you see my face at your hour of death, don't shake. Don't shake in your boots, no, don't you fret. Cause I'm gonna take you down where the beats are pumping. Down the hell where the lava's jumping. In the mountain, lava's jumping. Down the hell where the lava's jumping.
Let yourself fall, but you only get higher. Let yourself drop like a bee on fire. Living half dead, so you might as well drop. Cause can't find you, the beat don't.
Hello, how's it going? Hi, my name's Ian Carroll. I'm a crafter at Eighth Light, and this is going to be a Code Kata performance. With me today is Austin Melchior. He's one of our former apprentices. Um, under normal times, Eighth Light offers a 4 to 6 month paid apprenticeship. In fact, most of us who are crafters at Eighth Light come through that apprenticeship. Our apprentices are a talented group of individuals on the trajectory to becoming great developers. They were more than 50% of the way through their apprenticeship curriculum when we had to suspend the program. They're great learners and will be great junior teammates on a software team, Austin being one in particular. Austin was my apprentice, and I've seen his skills, and they are excellent. We want to use our voice and this platform to see if there are other organizations where these people may find a fit. You'll see Austin's skills demonstrated here today, of course. But before that, Austin, why don't you go ahead and say hi?
Hey everyone, how's it going?
Before we keep going from there, one of our moderator today is Brian Porter. Brian, can you hear us okay? How are our audio levels? Is Austin a little low, for example? Just want to make sure we're getting that good. All right. I think we should be okay. I'm going to just pump up the volume just a little bit when you start speaking. That way, in case there's some audio issues going on, I'll just watch the levels. Brian Porter is our, thank you, Brian. Brian Porter is our moderator today. Please respect the chat rules. Some other things, some other people I need to thank: Nicole Carpenter for setting this up. And I also need to thank the people who produced the music that you heard at the front of the stream. That is Made Up Music, and they're actually another Twitch stream, Twitch channel right here on Twitch, which is where you find Twitch channels. They're called Outpost 13, so you can find them on Wednesdays right now. Definitely check them out. Their music is free. I went ahead and donated some money to them for the use of the music this time around. Austin, what can you tell us about what a code kata is and how you're going to perform it?
Sure. A code kata is it's basically a code challenge designed to test your skills as a developer and help you to develop good practices. So we've got one today called the String Scanner Kata that's been done by previous apprentices. And so the goal of this particular kata is to replicate some of the functionalities of the String Scanner class in Ruby. And so my challenge today is going to be to take this String Scanner Kata and perform it in both Java and Elixir, which are vastly different languages than Ruby. So
before you continue, I just need to say that when I was an apprentice, I did this as my first exercise. I did it only in Ruby. That was hard enough. It took me about 2 weeks to really hone how this works with my mentor, Dave Moore. Austin did it in a week with 2 other languages that weren't Ruby. So I just need to point out exactly how completely epic that actually is. You're going to see it in a second here, and I don't want to, no pressure here, Austin. Can you tell me why it is that we do katas in your own words?
Yeah. Well, like I said, the purpose of them is to kind of practice and hone your skills. The way we approach katas is differently than a lot of other people in that we approach katas from a test-driven perspective. We use test-driven development to get our way through the kata, whereas a lot of people go on these kata websites and stuff that already have tests written out, and they just perform the code. So we add that little bit of challenge, that little bit of extra challenge to the kata.
What is it that you find is so great about test-driven development, Austin?
Test-driven development ensures that you're writing code in a manner that allows you to build a product that makes sense from the perspective of the developer. What I mean by that is it allows you to write cleaner code by forcing you to write code in a way that's easy to read, and that has a set of tests to kind of make sure that as you continue developing, you're not breaking previous code that's already been written, that sort of thing. So it's super valuable skill to develop, and something that I recommend everyone do.
Awesome. Well, I think that's probably enough of an introduction. So let's go ahead and, if you're ready, do you need to do any stretches or anything like that before you start?
No, I think I've covered all that. So
Okay, cool. Give me a second here. Let me just bring us so that you can see the screen a little better. That should be good enough. I'm going to hide myself now. And when you're ready, we'll begin.
Cool. We'll get started in a second. I just want to make sure it's clear. I do have a couple sets of acceptance tests already written out and in a different file. I'm starting each one from a completely blank project, basically. So I will be pulling those acceptance tests in and starting from there and going. So we'll get started. All right. So we're going to start with Java today. And so I'm going to pull in the test hookup and start creating my acceptance test class and pull those acceptance tests in. And because Java is a compiled language, I'm not actually going to be able to run any of my tests until I get the compiler to compile the code. So I'm going to use the tools in the Eclipse IDE that I've got here to kind of build out a basic structure of what I'm going to need. That's actually not correct. And we're going to create this class. Cool. And then I'm also going to add a string scanner test class.
What kind of test is that, Austin?
Which one?
The string scanner test class?
Yeah, that's the unit test class that I'm going to use. So I've got two classes: the acceptance tests, which define the acceptance criteria, and then the string scanner tests, which I'm going to use to develop the Kata itself. I'm just going to organize here. Cool. All right, so just go ahead and generate these. And I need to import assert equals. And we're just doing some pretty basic setup here. I'm going to use context hierarchies. So I'm going to import that, and that's going to be imported as well. I just spelled this wrong. 6 runner, oh yeah. That's what it is. Cool. So we're at a point where the tests will run. Great. And I'm getting no contexts found. That's because I don't actually have any tests yet in my string scanner. So we're going to start off with this end of string method. I'm going to call it end of. So we're going to start out there. And cool. And this just has to be imported. And let's see. Cool. So now I've got a running test suite where this test suite is passing, but the acceptance tests are not. So we're going to go ahead and get started. And actually, this is not the first test I want to run. So I'm going to just change this. First thing I want to do is make sure that my string scanner object is initialized with a string. So that's what we're going to do. And get my semicolons. Expected. Our expected output's going to be it's going to be the same as string, so I'm just going to set that to string and then get the string from the string scanner.
I see that's an arrange act assert pattern you're using. Is that right?
Yeah, I am. I think that makes the tests a little bit easier to follow, a little bit easier to read. And so I'm arranging the test here, getting some stuff together. I'm doing some form of action, and then I'm asserting, well, don't do that. And then I'm asserting that that action did what I expect it to do. So get string's not defined, so we're going to go ahead and get this test to pass. String. And when we've got a private variable, we need to get add getters and setters for that. And because I'm not going to be setting this outside the class, I'm going to go ahead and make set string private. And so now get string compiles, and we fail our first test.
Yay!
Set string to string. And so this should pass our first test. So our first test is now passing. Now we're going to move on to actually testing out end of and then scan. So test and public. Cool. And I'm going to just, a lot of this setup's the same, so I'm going to just copy and paste it for now. And our expected is actually going to change to a Boolean. And we expect false. And our actual is also going to change to a Boolean. And we expect expect, or we want to grab it from the end of method, our scanner. So now this is failing because this expects us to return an object, but I'm casting it to a Boolean, so we're going to change this to Boolean, and that should make us be able to run the test. Not exactly. We need a base return value. All right, so that test passes because the expectation's false. I'm just going to make it fail real quick just to make sure. Cool, so that fails, and then to make it pass, the easiest way is going to be to just set it to false. All right, cool. The next test, we need to make sure that when the string is empty, we return true. So we're just gonna true if at end of string, and we'll just pass an empty string to start, expect true, and check our test. Cool. And to get both of these tests to pass, we need to actually do some logic. So I'm going to grab our string, and I'm going to check if it's empty using Java's string methods. Cool. So that concludes end of. We're going to move on and work on scan. All right, so the scan functionality, the string scanner scan method is really interesting because it takes a string and it's designed to process that string one step at a time. And so it takes in a regular expression, looks for a match of that regular expression, and if it matches, it returns that one. If it doesn't, it returns null. And it allows you to process a string a little bit at a time. So match if found. So we're gonna start off by just saying that scan returns a match. Again, I'm gonna just grab this stuff. We're gonna just match on the string ABC and set up a regex pattern. ABC. All right, so we need to scan it with our regex pattern. And, our scan method needs to return a string. Cool. And that's going to not compile because we're looking for an object, not a string. Now that compiles, we'll run our test, and we're expecting ABC, but we're getting null. So I'm just going to return a string. That's what I want, actually. Cool. Cool. So that passes our first test for scan pretty simply. Now we're going to start getting into a little more of the complicated behavior. This actually needs to return the match only if it's first. And well, we'll call it next because it's the first part of the string, but it's going to be the next match. So that's what I'll call it. We'll returns next match, right? Cool. So our regex is going to be ABC, and we're going to expect it to return ABC. And let's take a look and see what we get. So we're expecting ABC, but we're getting the full string ABC, D, E, F. So now we actually have to do some logic to match on our regex pattern. So string to be matched, string equal get string, and I need to set up the pattern matching using the regex library built into JavaScript. So we're going to do pattern file the regex. Okay, and then matcher with string. Cool. So we compile a regex pattern. Using the regex pattern class, and then we get a matcher object also from the regex matcher class from that pattern, and we basically just want to return m.find that pattern, and we want to return the first item in the group or null. Oops. Cool. So we're going to use our matcher to find a pattern based on the regex that's given and what we're trying to match from. We're going to grab that match group. We're going to grab the first item from that match group and return it, or we're going to return null. So that should pass our next test, and we'll move on to the next one. Returns null if match isn't first. And so we're going to add a little more complexity to this. The regex pattern I'm going to search for is going to change now. I'm going to look for any spaces instead. So the spaces are not first, they're second. So we're going to grab the spaces, and our expected is going to actually be null. And let's take a look and see what happens. So we're expecting null, but we are actually still matching a space. So we've got to account for that. So just going to pull this into a Boolean now. And if match is found, we're going to return, well, let's see. I'm just going to do this refactor one step at a time. All right, so this, we should still be failing a test, but it should be the same test with the same failure. So now what we need to do is check if the match is the first item and only return it if it's the first item. So if the way we're going to do that is check to be matched starts with. And I'm going to extract this out to a variable as well. Cool. So let's compile that, or let's run that. Okay, cool. So that passes. And now we've got one more caveat. We need to make sure that as the string finds its match, we remove that match from our original string. So we're going to remove the match from the original string, and we're going to change our matcher to any word. And so the expected is going to be the remainder of the string after the match. The actual is going to change. So we're going to scan it, and then the actual is going to actually be scanner.string. That should work. Cool. So we're expecting DEF, but we're getting ABCDEF. We're getting the whole thing. So we need a little bit more on this one to get this to work as expected. So if the match starts with, or if the string starts with the matched, then we need to do some changes, right? We need to change the string by removing the match from the string. So let's see, string new string equals to be matched dot substring match length. And I'm going to just grab the match length here. Cool. And once we have our new string, we want to set our string to our new string. Cool. So now we've got passing unit tests and passing acceptance tests. So we've got all greens on everything. So this is kind of cumbersome. I just want to make maybe a couple refactors to clean it up a little bit, and then we'll move on to the Elixir version. I think I've got time to do that. So
What's looking strange to you there, Austin?
it's the all these nested ifs kind of makes it a little hard to read and figure out what's going on. So I'm going to just extract some of this logic into some helper methods to clean this up a little bit.
Nice.
So I'm gonna get this get new string method, and I'm gonna do set new string. And I'm just gonna kind of extract this stuff into here and call that method with our match. Actually, this is going to be a void. Cool. Let's check our test and make sure I didn't totally break everything. Good. This is the benefit of test driving things.
Yeah, nice.
Let's see here. I think we can extract this. Starts with
that nested if.
That, yeah, nested if out.
Yeah.
So private boolean going to take in a match again. And what I want to do is turn this into a ternary statement.
Yeah, that looks pretty.
And that's only returning it. I need to set the new string too, so maybe not quite that wise.
Well, you might need two then. Perhaps there's maybe one helper method is not only returning the match, but also setting the string while it does that. So it's that side effects thing, right?
Yeah. So why don't we just do this? Return the match from this after we set the new string, and then we can do this. I remove my logic before I put it in my method. Let's check that out. All right, so we're still passing everything, and I think I got to move on to the Elixir version now.
Yeah, you could spend forever refactoring if you want to, but you did it. So that was that red-green refactor pattern, right? You want to describe what that is?
Right. Red-green refactor is it's a pattern of test-driven development where you start off with a failing test, move on to getting that test to pass, however we can, and then refactoring that to be nicer, cleaner code after we've gotten the test to pass. That way, we've got we have the desired effects of the code, and then we can use the tests that are testing that code to refactor it into something that's a little easier to read or a little easier to follow, or that separates the concerns. So cool. And that's the pattern I've been employing this whole time. Even when I start my tests, I'm making sure that I'm going through that same red-green refactor cycle. So
yeah, you got some comments in the chat too, by the way. One thing here is live coding is hard. This is great. Someone else just shouted green when it became green. And then Ian AOX says that was some nice cleanup.
Thank you. Appreciate it. Cool. So we're going to move on to Elixir, and Elixir's a little bit tougher for me, so bear with me on it. Let's see here.
This is your first. This is your first exposure to Elixir, right?
This Kata is my first exposure to Elixir. So I'm gonna just go ahead and create my string scanner module, and okay, cool. I'm just gonna grab these because they're the same. And this is gonna go here, and I'm gonna do scan. There we go. We called it string scan here in our acceptance tests. So we've got actual failing tests. That's the acceptance tests failing. So we're going to start similarly to where we started in Java. Elixir is a functional programming language, not an object-oriented. So we don't actually have objects to work with. So we've just got to pass data back and forth to our functions. And that's what this acceptance test is doing. It's just grabbing the results of each scan and passing it into a new scan with a new regular expression. So we'll start with end of, since we don't actually have objects to manipulate the way we do in Java. So end of has an arity of 1, which means it takes 1 argument, and it should return false if string is not empty. And string equals CF. End of See, now I'm putting semicolons where they don't belong. Assert that expected is equal. All right, so let's go ahead and check this out. Now we've got 2 failing tests, and the issue is that end of is undefined, which is what we expect. All right, let's see here. Cool. So we're returning false from end of if the string is not at its end. We're going to add another test. Check if we return true when the string is empty. Okay, and again, I'm just going to pass an empty string and expect that to be true. And so those tests should fail. All right, expected true got false, and we're just going to return whether or not the string equals an empty string. That passes both of our end of tests. We're going to go ahead and move on to scan. And scan is going to have an arity of 2, meaning it takes 2 arguments, and it should return the match and remainder if the string matches, if the regex matches. Cool. String is going to be ABC. Our regex pattern is also going to be ABC. We're going to expect a result of our match and an empty string because it should be giving us the empty string if we have a match. We're going to scan with our string and our regex. All right. So scan is not defined. Scan, not scam.
String scammer.
Cool. And for this one, we should be able to pass this test by simply returning ABC and an empty string in a list. Oops, return isn't a keyword in Elixir. Cool. So we've got that one to pass. We're going to move on to remember, we only want to return the match and the remainder if the string starts with the match. And so we're gonna actually change this to ABC, DEF, and match on DEF. Still match on ABC, and we would be expecting DEF as our second item in our list, right? So now we got to actually do some work with the matching. So I'm just going to delete this because it's irrelevant now. So I'm going to use Elixir's built-in regex. Let's see here. Result equals regex. Built-in regex module. Scan using that regex module. And I'm going to scan with the regex that we take in. And I'm going to scan our string. That's results. That's multiple results because scan returns an array of, a list of lists that have the match in them. So our actual result that we're grabbing, because we only want the first match, is going to be list up first for our results. And then we want to return our result. And let's just say DEF, space DEF. And oh, that doesn't work because our first test is expecting an empty string.
Yeah.
So we have to go a little further than that. So we're gonna have to get a new string and set that equal to our original string, the substring of our original string, right? What's the equivalent for that in Elixir? I think we need to grab, it'll be slice, and we need a range. So I'm gonna grab the results length, string dot, let's see. Set a range up equal to the length to the -1 index, and then have our new string equal to string dot slice with our string and our range. And this should be new string. I'm missing here. Expected. New string's not being set. Oh wait, that's the whole string. I need the result. There we go. That was awkward. Okay. Cool. So we've got our match and our remainder if there is a match. Now we need to check if the match isn't first, we want to return nil and the original string if the string does not start with the match. Okay, and I'm going to use a similar regular expression, And our expectation is going to change to nil and A, B, C, D, E, F. And that should be good. Cool. So we are actually matching instead of returning nil. So we've got to make some alterations here. So if dot starts with string and result, oops. We want to return all of these things. Otherwise, we want to return our nil and our string. There we go. And then that's scan working the way it's expected. It looks like our acceptance tests is looking for end of as question mark. Now our string scanner test is looking for it without the question mark. Cool. All right, so this is an error I've seen before. It's no function clause matching in list first. Basically, where is this working? Where is this happening? The 12th test, 12th run. So once we've reached the end of our string, our regex scanner is just returning an empty list. So we need to account for that. If equals an empty list, do nothing. Otherwise, do this. There we go. Okay, cool. Ian, how much time do we have for me to go through and refactor this a little bit?
Yeah, go ahead and take some time. I think it's all right if we go over. There's no shows coming after us.
Okay, cool. We'll take a few minutes and refactor this then. Let's see. We're going to do a private method of get new string, get new string, which takes in string and a match. And I'm going to extract this into here. This needs to be match. And this is going to be get new string. Cool. That should where are we getting that? Line 24 result should be match. There we go. Cool.
Nice.
So it's a private method that gets a new string. So it takes in a string and a match, returns the new string that needs to be returned. And I also don't like this. This is kind of long and cumbersome. So I'm gonna make a private method for that too. Results. Cool. So that's going to take in some results, and then I'm just going to grab these and just kind of expand them out a little bit. Cool. Try to decide if it's worth extracting this if statement into its own function. The lack of ternary bothers me because I like how much ternary compacts the code a little bit.
You don't get that that little trick to sweep it under the rug in this language.
Right. That should still pass everything. Oh, no.
You're not calling it, are you?
I'm not calling it. Good catch. There we go. All right. I think that's enough. That takes our public method and makes it pretty readable and extracts some of the kind of dirtier logic out to these private methods. Anything else you see there, Ian? You think I could tackle?
Not seeing too much. I mean, yeah, we could spend forever just sort of working on it, just fussing with it some more.
Right.
But I think I can't remember who said it. Maybe it was somebody in the chat might know the phrase "make the change easy, then make the easy change." I'm pretty sure it's Martin Fowler or somebody like that who said that.
Yeah.
So that's there's a pragmatism to exactly how far you want to refactor.
Right, for sure.
Yeah.
Cool. So if you guys want to check out Josh's version in Ruby, you can Ian, could you toss the link to this?
Ooh, yeah, maybe. Let me just see if I can find it.
Here, I can toss it to you.
Oh, okay, sure. So now comes like the part where we're going to interview Austin just a little bit and ask him a few questions. Chat, you're welcome to ask him questions yourself. In the meantime, I'm going to ask him a few things that I think would be interesting for him to talk about. Did you pass me that? Like, did you pass it to me as a Slack?
No, Zoom chat. I've got my Slack off for this.
Oh God, yeah. Let me find it. I gotta open it up. Everyone's gonna see this. Hopefully, I actually copied it.
I've actually, so my first exposure to Elixir was this Kata, but over the last week or so, I've been working more with it. And it's tough because I think the biggest thing that was tough for me was shifting from my head does object oriented like naturally, because that's what I've absorbed myself in. So switching to functional languages, that was really tough. And I'm by no means am I, very good at Elixir at this moment in time, but it's really fast. It's something that I noticed on the project I'm working on. It's really fast, much more so than something like Ruby. So that's interesting to me.
Yeah, Elixir is designed to be really fast. It's built on top of Erlang, which is used for telephony. So, yeah, it's supposed to be super duper fast. Cool. Now, you've been working on an Elixir pro bono project lately, right?
Yeah.
Yeah, and so the first thing I had you do was to take this Ruby kata and write it in Elixir. And you found a way to do that, but then I remember right before the stream you were saying like, oh, I don't even know if I can do this anymore because of how different your view of Elixir is now than how it was before, and how your old solution doesn't really make that much sense to you.
Right. Yeah. It was interesting working in Elixir as much as I did this week, because I could see how functions can be designed in a way, the different functionalities with pattern matching, overriding method calls with by using pattern matching to determine what the arguments are being passed into it and stuff like that. I can see this being done in a way better way than how I just did it. I just didn't have time to think through how that would.
Yeah, you'd have to practice it again in a totally different way, right?
Right.
Yeah. Cuvuglio, if I pronounced your name right, Cuvuglio, has a question. In your opinion, at what point does extracting private methods out fall into the iceberg anti-pattern?
It's a tough balance to reach, right? I think that there's an extent that it is valuable to extract to private methods so that to make the public API a little easier to read and whatnot. But I haven't done a whole lot of reading on the iceberg class anti-pattern, but what it sounds like to me is you're basically hiding under the water, right? You're hiding a lot of the major logic and only showing a little bit. And I'm not too familiar with the problem that anti-pattern suggests. So I don't have a great answer for you, candidly, but.
I happen to know whose name that probably is. That sounds like that question is coming from my old mentor, your grand mentor, as it turns out. I remember him talking about this once. Basically, what he's talking about is like after a while you get so many private methods that it's mostly private methods, and in that case, like the complexity is just being swept under the rug. So once you get to a certain number of them, you can start to look for things that are similar that have like a certain responsibility. You'll probably have more than one responsibility in that giant MISC bucket of private methods. And that can actually be abstracted out into its own class.
Right. Okay.
Yeah. So yeah, that's how you would extend that, because after a while you just get like a 1,000-line long piece of code that has 3 lines of public method followed by 980 lines of private.
Right.
Yeah. So
Yeah. No, I can totally see how that can point to you know, maybe needing an abstraction and that sort of thing. So.
Yeah, so there's some comments about here. How about Knuth-Morris-Pratt algorithm? Have you heard of that one before?
Nope.
You mind Googling that for a second while I look at the next one? Happy Hippie Hippo says you should only pull to private if you need to eliminate duplication. Other reason is a no reason. Yeah, I have opinions about that, but you might have some as well, Austin. Maybe you have some thoughts around that notion of not pulling out into a private method.
I don't necessarily agree with that. I think pulling some complexity into private methods and utilizing the naming of those methods can help you write clearer, cleaner code.
Mm-hmm.
And so I understand the argument that it should only be for duplication elimination, but yeah, I don't agree with it. I think that writing clean code is more than just eliminating duplication. I think it's also writing code in a way that other developers can look at what you've written and understand what's going on, especially for methods that are exposed to the public. So.
Mm-hmm. Yeah, so that gets into naming things. I know several times during the code you abstracted something out into its own method, or you gave it more than just a 1-letter variable for a name. Why did you go about doing that? Why not just leave everything with 1-letter variables and put it all in one file, or in all in one class? Yeah.
Same reason that I, just mentioned. It's to help write code that is easily readable for myself in the future, and anyone else who might look at the code in the future. It's super important, especially when you're working on projects where there's multiple developers, or that project is a project that will last for a long time, and you should expect your projects to last for a long time. And going back and trying to read legacy code and stuff can be really difficult, especially if the developer who wrote that code didn't take care in figuring out how to write the code in a way that's easily digestible to future developers or other developers on the team. So.
Mm-hmm. Yeah, that seems fair. And it is really an art, right? When to abstract something out and when not to, because there are times where, you probably, that information should be exposed to the top level rather than abstracted away to the point where you can't find it anymore, right?
Right.
Yeah. So I had you do this. I gave you an example of Josh Cheek's Kata in Ruby, and I asked you to do it in Java and Elixir. Do you have any opinions about Java versus Elixir versus Ruby at this point?
Well, for one thing, you can't compare Java and Ruby to Elixir. You can maybe compare Java and Ruby to each other, maybe, but not to Elixir. So it's hard to draw, a conclusion such as that. What's better than the other? I think both of them have their use cases, and a lot of people prefer one over the other. It's honestly ends up being a preference thing, I think, more than anything. But I like Elixir a lot more than I thought I would coming into it, and I really like Java as well. So there's something about the strongly typed nature of Java that kind of draws me, even though it's the fact that it's more verbose and whatnot. Mm-hmm. So they're all different, and a lot of it, I think, comes down to personal preference.
Yeah. So I'm seeing another question in the chat. Maybe you can continue looking up the Knuth-Morris-Pratt algorithm. What is the difference between a private method and a public method? What is the difference between a private method and a public method? And what is the difference between a public method and a private method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference between a private method and a public method? And what is the difference bet especially in an FP language, lean on immutability and referential transparency. Then the difference between public and private is more than just an API design choice. I was reading that and didn't actually parse what I was reading as I read it. Did you catch that meaning?
I'm rereading it. Give me a second.
Sure. And I'm reading another response from Happy Hippo. Okay, yeah, I guess that's fair. It just depends on how you like to write the code. It might just be a difference in style. Happy Hippie Hippo, and that's fair. It's totally fair. For me, I think when I started learning software, I didn't really understand very much of it, and I didn't like looking at long things, so I would just start abstracting it out and naming it so that I could understand the pieces better. And then I got into the habit of just having lots and lots of little abstractions that are all named. I think I might have passed some of that opinion on to Austin as well, just being a mentor. But yeah. Austin, any thoughts?
Yeah, I mean, I think there's a danger when it comes to having really long code as well, and the danger I see is, especially if you've got a bunch of branching logic and whatnot within that code, you as a human can only process so many different branches, right? You as a human can only process what's going on, and longer code ends up being a lot harder to figure out what's going on across the entire thing. And I have experience with that, right? One of the projects we worked on during my apprenticeship was a legacy project, a legacy tic-tac-toe app that was written all in one file, all completely through, with just a ton of branching logic, and it was a lot to process, and it's not that the code was completely unreadable, but it was more that I couldn't follow what every branch was doing throughout that entire long method. So extracting those out into smaller methods that handle each type of branching, I think is going to help other developers to understand what's going on.
Happy Hippie Hippo, also, I'm learning how to say that quickly now, you'll notice. It said something else that seems really kind of like a cool thing as well, that the code, if it's too long, is probably doing too much stuff anyway, and it's breaking the single responsibility principle. Yeah, that's another way of looking at it, is just trying to figure out where the responsibilities lie. And yeah, now that you mentioned that, it makes sense, the idea of abstracting it out based off of dependency rather than based off of just what the current job is. So that might be another way of breaking up the code that you can start to decouple it based off of its dependency. Yeah.
Let's hop back to the Knuth Morris Pratt algorithm.
Oh, sure.
Just real quick, because I'm going to brush it off because I've never studied it or heard of it. So yeah, I mean, I'm sure implementing any sort of sorting algorithm that actually handles the sorting is probably better than the solutions I ended up using, but I just don't have experience with it, and obviously that's something I need to learn. So
well, I'm sure other people have already implemented that algorithm as well, and
right.
Probably if it's it sounds like it's a pretty famous one, so if you use that one, it's probably under the hood someplace in one of these languages. And to be fair, Kata is a conceit on this. It's an exercise. It's like lifting weights. There's no real purpose to lifting weights. You're just picking up a weight and then putting it back down again over and over and over again. The particular algorithm here, yes, has been solved, has been done a lot. But the purpose of a kata is for the practice of getting it into your muscles and into your bones, how you would go about creating code. Now, granted, test-driven development isn't going to necessarily bring us to recreating that famous algorithm. But that's really not what is being demonstrated here, is not whether or not we get this algorithm right. What's being demonstrated is how you can approach writing software that nobody has written before, and that has a lot of branching logic and a lot of complexity to it. And how do you manage that? So that's sort of the benefit you get from doing katas. Do you feel like...
I do want to say thank you for bringing up the algorithm. It's definitely something that I want to look into, and learn more about. But yeah, it's just not the direction I took with this particular kata. So
yeah. Okay, cool. Yeah, so it's a little different from that general explanation. Yeah, that's okay. Yeah. So yeah, the purpose of the kata is to display test-driven development practices. It's really more about the practice than necessarily the solution in this case.
Right.
Although it will produce clean code. Now, Austin, my question for you is, after doing these katas so many times, do you feel like your natural approach to software is different than it was before?
Yeah, I think doing these katas and the way that they developed me was giving me a kind of better understanding of what test-driven development is, and the red-green refactor pattern with test-driven development and stuff. Kind of building from the ground up and using tests to drive that development is super valuable, and I think this really helped drive that point home for me. So
cool. Yeah. You've done this. Some other languages I think you've touched, right? Python. You did do Ruby, right?
Yeah,
and
Ruby.
JavaScript. We worked with React and TypeScript on something that had no tests, right?
That was fun.
What was also really interesting about that was that when we approached that, like my first thought with that project, because that was one you and I paired on, was that like, oh, well, they're not using tests, I guess we should just not use tests. And your response to that was that, no, we should still write good, clean code the way that we always do, and we'll go faster by doing it that way. And I'm glad that you brought that up, because when we started driving it that way, we actually delivered it on time and actually at a higher quality than what would have been had we tried to pick through the untested TypeScript code.
Right.
Yeah. So yeah, but point is that you've done a lot of things in this apprenticeship. How do you feel about it?
I think the work that we did definitely made me a stronger developer, and helped to develop and focus on some skills that maybe were a little lacking before I joined 8th Light.
Mm-hmm.
I'm super happy with how far I've come, in the relatively short amount of time that I've been with 8th Light, and I think that that's going to help propel me to being a better developer, than I would have if I hadn't taken the apprenticeship with 8th Light, and that's super exciting for me. So.
Yeah, well, from what I've seen you do, I'd want you on my team. Yeah, so I think we can end the stream here. Thanks everybody for watching, and I hope you learned something, or maybe we can use this for I can use this for other apprentices later too.
Yeah, I actually want to address that last question there real quick. Happy Hippie Hippo.
Yeah.
Asked, how do you approach tackling legacy spaghetti code? How do you start the cleaning of that mess? I'm going to go back to my experience with that single page tic-tac-toe code that I told you about earlier. The best way I found to start is by writing tests. Write characterization tests that sort of help you to figure out what's going on in the code. So, take a look at a piece of the code, write a test that checks if that code is doing what you expect it to do. And if it is, great. But if it's not, then update your test so that that your test reflects what that code is actually doing. Try and get as much characterization tests as you can, and then start refactoring a little bit at a time. Again, using test-driven development, you can take pieces of that code. Once you have the characterization tests around it, you can refactor it into cleaner code and be fully confident you're not breaking the app as it stood. So I think that's probably, in my opinion, that's going to be the best way to approach refactoring of just a disaster of a code base, which far too common in this day and age.
Yeah. I won't mention whose code that was that you were working on, but yeah. I think we'll end there.
Cool.
So thanks everybody for tuning in. Hopefully we'll be able to do more things like this in the future. Again, thank you very much, Austin Melchior there. Writing code in front of everybody, doing a live demonstration, that's very impressive. So thank you.
No problem. Thanks for having me on.
Yeah. All right. Bye for now.
See you guys.